Okay, so today I'll spend the time, instead of using a lot of slides, I will be sketching things in Excalibur because they're just things moving around. Hopefully will make less people fall asleep. So let's start at clouds and APIs. As you can see in this drawing, basically, I just want to make the point before I jump in, and I know the crowd here doesn't really need to hear this, but still, it's good to understand the context in which we are moving. And right now, what the most important aspect for my talk of cloud environments is the fact that we these days have infrastructure that has APIs. Everything can be manipulated programmatically. And in this new world, we basically need different way of thinking. Basically, there is no more excuses for not automating things. And we have a lot of different ways to automate stuff. And I will be showing my favorite one today, which is Kubernetes operators. So welcome to my talk, Automating the Enterprise with Kubernetes Operators. Feel free to follow me on Twitter for related news and retweets and whatever. And yeah, let's jump in. So today I will be talking about a real-world project I did with one of our clients, which was a large enterprise company. Some of you here probably already heard about this project. It's the same project I keep talking about because there's just so much good stuff happened there that I still have things to say. The new thing about this talk compared to other talks that were addressing aspects of this project is that now I'm really going to focus on the operators and what we did there, and why I think operators are a great way to automate the hell out of your infrastructure problems and processes and everything. So let's start with what exactly was the goal that we needed to achieve. Basically, we were focusing, our team was working on a CI/CD system for rolling out to up to about 100 development teams in this large company, and that meant that everything we did had to be multiplied many times. So basically, we couldn't just, let's say, create a nice pipeline and say, here, use it, because it had to be usable and easily provisionable for many teams. And I'll try to focus as little as possible on what the actual CI/CD system did. That was what I addressed in other talks, but I have to talk about it a little bit to explain what are we going to be talking about provisioning today. So this was an environment built on OpenShift. So what we had was a bunch of OpenShift clusters. For those who don't know, OpenShift equals Kubernetes for our intents and purposes. It's Red Hat's version of Kubernetes. All your knowledge about Kubernetes is completely applicable here. So somewhat simplifying things, there was an OpenShift cluster for hosting all dev environments, an OpenShift cluster for hosting all staging environments, and actually multiple production OpenShift clusters, but we'll be simplifying that to prod. So the dev cluster would hold the dev environment of team X and team Y and all teams, basically, and then also the staging cluster would do the same, but with the staging environments and etc. And so it goes to production. We needed to deploy containers to these environments and then push them through a pipeline, landing them in production, ideally, if all the tests were fine. We did this with a GitOps approach, where every environment had a corresponding Git repository inside Bitbucket. So there is Bitbucket up here. and Bitbucket was holding a GitOps environment for Team X dev. So there was a, oh nice, my mouse is running out of battery. Let's hope it lasts until the talk finishes. If not, I'll find the cable real quick. So every single environment of every single team had a corresponding GitOps repo where all the YAML files were stored. There are other ways to do, if people here who have done GitOps did something different, maybe having one repo for all environments of a single team or one repo per cluster, that's all doable. This is the way we did it. Then another thing that we did was CI pipelines were based on Jenkins, and every team got their own Jenkins in their dev environment. So this was also basically a platform feature that you get your development Jenkins where you can build your containers and run your unit tests and all those things. Finally, these GitOps repos needed to be, again, these are GitOps repos, which means that they hold the Kubernetes YAML files that describe what needs to be deployed to an environment. They don't hold the source code. The source code is in yet another Git repo, and those ones we did not consider part of the platform, so we did not provision them. So these GitOps repos, the point of these is that whenever you make a change to the YAML files in here, things get synced to the environment down here. And this synchronization also needs to be set up for every environment because, well, it needs to happen. And these were, we didn't use Flux or Argo CD because they were very new at the time. So we rather just used Jenkins pipelines to do these. And those Jenkins pipelines lived in special Jenkinses that had, like, each cluster had one. The important thing is that the Jenkins pipeline had to be provisioned for each environment. So this was the challenge. Whenever a team came to us asking for that they want to be deploying, they need a dev environment, staging, and production. Basically, all the teams needed pretty much the same stuff. Then we needed to create all this for them and do that in a user-friendly way. We intentionally went through the pain of actually doing this using basically ticketing, emails, and however teams would reach us, just to, like, test out the process, how would this all work. But that, of course, got boring really quick, and we needed to automate the whole thing. And we opted to do that using Kubernetes operators. So let's now jump into and open that can of worms for the uninitiated here. What are Kubernetes operators? I'm gonna do the really quick version. Hopefully that's gonna give you a good enough idea to see, especially together with, like, going into the whole more complex setup that I'm going to show here. So Kubernetes operators are basically a process running on Kubernetes that does things. So it's a pod, an operator pod, that is just a process that talks to the Kubernetes API. So here is the Kubernetes API. And the Kubernetes API itself is basically a key value store backed by etcd that stores all kinds of objects. For example, it stores deployments. Let's rather say replica sets. So whenever the Kubernetes API server gets a replica set from the operator, let's say me saying kubectl, apply my YAML file, I enter a replica set into the API server, there is going to be an operator that actually is a core part of Kubernetes. And what that operator will do, it will create pods for this replica set. If this replica set specifies it needs 2 replicas, then the core Kubernetes operator will create 2 pods. And what's more, what this operator will do, it will constantly monitor the replica set and the pods for any changes if they get out of sync because either the replica set changes and it says 3 pods now or 1 pod, or a pod just dies and then the number of pods don't match the replica set, the operator is going to reconcile that and make sure like reality, which is this, matches the specification, which is this. So this is how Kubernetes works under the hood. And this is a really, really good pattern because it gives that robustness that you don't even really expect when you start first using Kubernetes, but to really start relying on it later down the line. Because this algorithm basically can handle any situation. It doesn't matter how did a pod die. Did the operator delete it? Did it crash? Whatever, maybe the whole node went down that was holding this operator, this pod. It doesn't matter because this reconciliation algorithm will always figure out what needs to be done. Now, how like these core operators in Kubernetes are actually called controllers. Doesn't really matter. How do we make our own operators? How do we replicate this way of how Kubernetes works? Basically, Kubernetes supports us in that by making it possible to create our own custom resources. So custom resources are the same as normal Kubernetes resources, except we specify the schema and we can tell how they should look. So in our case, let's start with, we need to provision a Jenkins for a team. And we want to do that with an operator. So we will create a custom resource called Jenkins. The Jenkins custom resource will have a spec part, same like all Kubernetes objects have a spec. And in that we will specify, let's say, what version of Jenkins should we be using. I think that was, I don't remember if we had any other parameters for this. Oh yeah, we also specified which team does it belong to. And then it had a status, and the status had the URL in it once the Jenkins got created. So we just defined, this is basically an API that we are defining. And once somebody creates a Jenkins resource in the Kubernetes API, our operator goes and creates the actual Jenkins. Like this would be a Jenkins, well, we would create a Jenkins deployment that would in turn create a Jenkins pod or a replica set, and the replica set would create the pod. So, but our business logic in our operator deals with creating this Jenkins deployment. So this is all great, but what is this operator really? The operator is basically just a pod running on Kubernetes that registers a watch on the Kubernetes API and then does things based on that, based on changes to its own custom resources. Kubernetes doesn't know about operators. It doesn't care. It's just another pod for Kubernetes that just happens to be listening to the API. So that's as simple. So operators are more like a design pattern, not a like functionality of Kubernetes. There are like the built-in operators that all just follow this design pattern. So we decided that we would like to provision all these things with Kubernetes operators. First of all, why did we decide that? Because what you could also do is you could just have maybe an API service that gets a REST request and then starts provisioning all these things, starts talking to the Bitbucket API, starts talking to OpenShift's API, starts talking to Jenkins's API to create this deployment pipeline. We could do that. However, such an API service would be quite brittle because what if this process fails somewhere halfway? So let's say there would be an API service that that would be the like provisioning API. This process would be quite brittle because if something, these are things that take long time. They can fail, network problems, anything. This API would either just fail halfway and have no idea what happened, how to recover, or we would have to add a database to it to record what has been done so it can continue and so on. So we would be building a pretty complex application. Now, instead of this, building operators or one operator means that we are leveraging the Kubernetes API as a database, basically, both as our API for inputs and as basically saving state and using it as a database. And what this also means is that not just we have a ready database there that just is great to use, but it gives operators also the option to type kubectl get Jenkins, which is a really good thing for people operating the cluster. They can just list all the Jenkinses, or they can list, as we will go to the other resources, they can list all deployment pipelines. So kubectl will act as the interface to the internals of the whole provisioning system, which is a really, really nice property to have. It's really useful to have that. So we now have a basic understanding of why and how do operators work. So let's jump a bit deeper and let's see the actual system that we have built. I already covered the Jenkins operator, so let's just continue from here. Let's make the Kubernetes API server bigger because we will need the space. And yes, all right. So our next operator that I will be showing is the Bitbucket operator, because we have to create Git repos inside Bitbucket. If you remember, each environment has their own corresponding Git repository holding the YAML files, holding the state. So we need to provision that too. And so we will have a Bitbucket operator. And the custom resource driving the Bitbucket operator will be a Bitbucket repo. Of course, this custom resource will again have a spec and status. And in this case, the Bitbucket repo will not have a version, but will have a name, obviously, the team it belongs to, and I think that's pretty much it. And the interesting part here is that the Bitbucket operator will not be talking to the Kubernetes API server the same way like the Jenkins operator does, because Bitbucket repos don't live on Kubernetes. So while it will be listening to Bitbucket repo resources changing, it will reach out to Bitbucket to actually make the changes happen. I'll try to route very carefully this arrow here. Perfect. Right, so because operators are in the end just code running in there, we can do whatever we want with them. So writing an operator is in the end harder than using something like Terraform or Helm to do stuff. But on the other hand, it's way more flexible because you can write the operator in any language. And now that we come to languages, I'd like to mention what did we use for writing operators. The majority of operators out there, especially ones that are like written for third-party products like Kafka and Memcached and whatever, those operators that are used to just install something on your cluster, they're usually written in Go, as Go is the go-to language in Kubernetes land. On our team, however, we had a whole bunch of Java developers, including me. So we decided that we will write our operators in Java. And we not only did that with great success, but we also rolled out a nice open source project out of it, the Java Operator SDK. There is a project called the Operator SDK, which is the Golang version of this. And we just basically copied the functionality of the Go SDK, rewritten it in Java, and this makes it, there is a whole bunch of stuff around building an operator that I don't have time to go into the details of today. But believe me, there is a lot of small things that is nice if it gets taken care of for you. And the Java Operator SDK just does that. Also, Java has a Kubernetes client in the form of Fabric 8. So let's say you would not want to use Java and not Go, but like any random language, you can use anything to write an operator. One thing you will need is a Kubernetes client. So you will need to talk to the Kubernetes API. And even though it's a REST API, it's pretty complex. You probably want to have a client, but actually most languages have that. So, okay, now that we got that out of the way, let's move on. So we have a Jenkins operator, we have a Bitbucket operator. We will have a deployment pipeline operator. So we will be adding this to our Kubernetes API. It's a deployment pipeline. You can see that we are practically designing an API here, right? We are, with these custom resources we are defining, we are exactly saying what can be created and what properties do those things have. And of course, we will have the deployment pipeline operator, and that will have, I won't even go into very much the details here because there is no point. There is not very super interesting parameters for a deployment pipeline. It's just the source repo and the target repo. And this one actually will be talking to a Jenkins running inside OpenShift. So this operator is again not, this will talk to the deployment Jenkins. So this operator is again not provisioning something on Kubernetes, even though the deployment Jenkins itself is running on Kubernetes. Cool. And then the last thing we are missing from this picture is we need to provision environments for all these well, namespaces that are the environments actually on the OpenShift clusters. So our final operator is the namespace operator, or actually not the final one. The last we will have one more, and that's the most interesting one. This is really simple what it does. Wait a sec. No, I'm getting lost here. No, I don't. We did not have a namespace operator because namespaces are a core Kubernetes thing, so we did not need that. No, sorry. I got a bit lost in my train of thought there. Now, we had something called the team operator. And that is because when a team comes to us, we did not want them to ask for deployment pipelines and Bitbucket repos and Jenkinses and so on, and namespaces. We wanted to wrap up this whole thing in one package for them. And we wanted them to just tell us, we are a team, we have these members, do magic for us. That's the interface that we give development teams. And that meant we have a team custom resource. This one I will detail here a little bit. So the spec of the team included the name of the team and the members of the team, and then there would be Adam and so on. So like we would have the list of members who work on that team. with usernames. So we can, for example, add them as users to the Bitbucket repo we are creating for them. And so we had a team operator to handle that team creation. Now, what did this team operator do? Operator. So this team operator talked to the Kubernetes API, created the namespaces, which we did not need a namespace operator for. Sorry about that. Actually, at some point we were discussing we might need that for reasons, but in the end we did not have that. So it would create the namespaces for the team. Oh yeah, the team spec also includes what environments do they need. So we would have, and which environment would be on which cluster, because this would be something that varied with teams. So there would be like dev environment on the dev cluster, staging on the staging cluster, but maybe they also have another test environment on the staging cluster, etc. So they would specify the environments and we would create the namespaces in all the places where need be. And then the team operator would also create all these resources that we defined as custom resources. So the team operator becomes somewhat of a coordinator and the manager of all the other operators through their custom resources. And this is, for example, because for example, the development environment namespace needs to be created before the Jenkins is placed inside it. So, or the Bitbucket repo needs to be created before a deployment pipeline can be hooked up to it. So the team operator would orchestrate the process of creating these other resources and launching with that, kicking off these other operators and making them do their work. So this is basically the view of the whole system. And now in the remaining time, I think I have about 10 minutes, I will just jump into a few of the design issues here. This, as you see it, if you're feeling that this is pretty complex, you're right. We had a few options here, and we decided basically to go with the most complicated one because it just kind of sounded cool. This is the classical question of monolith versus microservice. We could have put the whole logic inside the team operator. We could have done that even with just having a team custom resource and maybe keeping track of what's created and what not in the status of the team custom resource. So these are basically two choices. We could just have one custom resource and one operator and have this operator have this massive logic in it of creating everything. Second option, but that would be pretty hard to keep track of what's happening just in the status. The status would swell into like a really big object with tracking all the things that have been or might not have yet been created or failed to be created and so on. Second option is have just one operator, the team operator, but have all these other custom resources, but basically just create them and immediately handle them, right? Like create the Bitbucket repo resource, but have the logic to handle the Bitbucket resource inside the team operator. So that way we would kind of misuse the Kubernetes API as a database to dump these objects inside, but actually the operator itself would just be reacting on the team custom resource. So this is the option that we were later a bit regretting of not starting with, because the whole full microservice setup actually had a lot of like distributed system coordination happening in it. Like, you know, with the team operator had to be waiting for events when the status of the deployment pipeline gets updated, and when that event comes in, then it creates, when the Bitbucket repo gets created, then we start creating the deployment pipeline and listening to events when the status, for example, of the Bitbucket repo changes this URL from null to an actual URL, which means the Bitbucket repo is created. And then the team operator can go and create a deployment pipeline. This meant listening to a lot of events of different custom resources. and then handling a lot of edge cases of like, what if those two events kind of arrive at the same time, not exactly at the same time. Yeah, we had a lot of like classic microservice problems, exactly that you would expect to have in a distributed system. So the lesson learned there is that we should have probably done what is the right thing for microservices and just went with a monolith first and break it down later, instead of going the most complex route. On the other hand, I do believe that this architecture in the end is the correct one, but you should take it step by step to arrive here. Another interesting problem with operators is, oh, by the way, feel free to ask me questions on the fly. It's actually kind of easier to answer them while I'm still like in that topic than afterwards, but also there will be time. But feel free to interrupt me with a question. That's why we're on Zoom and it's easy to do.
We have on the chat. Should I?
Yes.
Yeah, so the first talk is great talk, loved it. Did you modelize the features that you exposed via Jenkins through the Teams operator? As I'm sure a certain team X does not want Y, so they can work on Z.
I didn't understand the question, sorry.
Yeah, so let me see. Did you modelize the features that you exposed via Jenkins through the Teams operator?
Did we modularize them?
Yes, that's the question.
We did not expose any features through Jenkins. So you mean this Jenkins, like that each team gets their own Jenkins?
Okay, let's wait for Ryan to maybe clarify a bit his question.
Oh, okay, David. So you're reading somebody's question from the chat right now.
Yeah.
Okay, yeah. Let's maybe do that because I feel like we're a bit getting lost in this. Okay, let me jump on the next topic rather. So actually, the last point I would like to make is that we have a lot of OpenShift clusters here, right? I'm gonna make them a little bit bigger. And the question is, and they each have their own API server, right? So the question is, where do we run our operators and where do we put those custom resources that we are using? So a lot of the times, this is an easy question for operators because they do something completely local to the cluster. So let's say the Kafka operator, you run the operator on your cluster, and then the Kafka operator will spin up Kafka topics and Kafka instances on that cluster. There is no question about that. However, in our case, we need to provision these namespaces across different clusters. We need to provision things that are outside of the clusters, and we need to keep track of what has been provisioned pretty centrally. So we also can't say that, like, one option would be to run an instance of the team operator on every cluster, but like one team operator would just be creating these namespaces, another team operator would be or each of them would be creating everything but just related to that cluster. That would be one solution. So we would have a team operator on the dev cluster, and then this team operator would, and we would have one on every other cluster, but each of them would deal with creating stuff related to that cluster, like just the environment that is on the cluster where it's running. We didn't do this because we wanted to have for operators one central place to say kubectl get teams. And with this, things would be very distributed, and there were like 4 or 5 production clusters and so on. So it would, with like too many clusters, there would be no way to like find everything properly. Then we were thinking of where to, okay, so we would just run one instance of the operators, but then where do we run them? Like, is this something you would run on production, or is this something you would run on your development cluster? And in the end, we realized that this is like a really important service that just needs this kind of the same constraints as your production applications. So in the end, the team operator got moved to the production cluster and had credentials to the other clusters to create stuff on them, which also helped with firewall rules, because already firewall rules were configured that other clusters can't reach production, but the production cluster can reach other clusters also on the networking level. So that was also an interesting choice we had to make. And there is just one funny story related to this, is that we also learned the hard way that basically the development cluster for us is production. So when our operators are manipulating development environments of developers, then that is not a development environment in the sense when you talk about your own development environment. For us, that is production. Basically, we were running some tests, and the tests cleaned up the cluster to start from a nice clean state, which meant destroying a lot of development environments before the test was shut down. So yeah, developing operators in such an environment, you want to have like an operator development cluster. You might not need a cluster, by the way. The reason why for us it was extra hard is that we were creating and deleting namespaces, which is like the highest level of encapsulation that you can have on top of Kubernetes, which means we don't have any encapsulation. Our encapsulation is just the cluster itself. So we needed another cluster where we can safely develop and delete things that nobody will mind us deleting. Yeah, if you're not creating deleting namespaces, then you have it much easier. So yeah, that's pretty much it. To summarize, operators are a really flexible way to provision things, whether it's infrastructure or some complex application where you're getting lost in like the Helm YAMLs or whatever. And especially, and what operators add to this whole provisioning thing is that they are constantly running processes. That means also, like, on one hand, they are written in some like fully fledged programming language, which means that you can do anything with them. And on the other hand, they are constantly running processes. So a lot of things that you would not really have place to put somewhere, there is now a place. You can like check in 2 days later if that thing is still up. Or as we had to do, yeah, I'll just I need to like touch on this a little bit. Sorry about a bit overrunning the time. But so we had to also create, besides dev environments, we had to create like PR environments. So just super temporary environments for testing pull requests. And we had a problem of when to clean these up, because like a Jenkins pipeline can be launched to create a PR environment, but then like when it becomes obsolete, that was hard to find out. And once we were doing this with operators, it just all became very simple, because the operator is constantly running. So you can like check every 10 minutes or listen to events from Bitbucket that the PR is done, and so on. So like it's the opportunities for automation really increase. However, it is not cheap to create operators. So so you need to get familiar. You do start small. Don't jump in with 2 feet, and keep in mind other options. But if you have like enterprise scale complex problems to solve, then operators are definitely an amazing way to solve them. And yeah, that was me. Thank you very much for listening. Oh, look, I have a slide about the Java Operator SDK. Please check it out if you're a Java developer watching this. This is also a really cool way to just get to know Kubernetes. If you write an operator, then you will learn things about Kubernetes you never thought you would want to learn. And yeah, that's it. And I'm very happy to answer any questions you might have.
Thanks, Adam. It was brilliant. David, I let you handle the questions. Really appreciate that you're here for that.
Yeah, we have a few more questions on the chat. So let's see. How much of the functionality of the lower CRDs did you expose in the team CRD? Or did you create the lower resources and then let the team tweak them?
Well, really good question. We barely exposed anything. So we just had like exactly like what I showed here. We only exposed very limited functionality here with the just members of the team and what environments do they have, which meant like how exactly is the Bitbucket repo configured. They did not have access to that, which included like we automatically determined that this is something is a production environment just based on which cluster is it on, and we set different credentials to that. So for the GitOps repos, for example, this and this repo would be managed fully by the team, but the production Git repo could only merge to by operations. And we could just set this up, all the correct permissions and everything from the Bitbucket operator. So, so a lot of this stuff was hidden and we did not let the teams tweak it. So in that sense, these operators were a bit of an, I wouldn't call it anti-pattern, but like not exactly true operators in the sense that these objects were never really meant to be created by anybody else than the team operator. But at least they could be queried by operations and at least check like, okay, how many Bitbucket repos do we have related to deployments? Not like a huge feature, but kind of nice.
Thank you.
Okay. So next question, how did you handle the dev cycle of the operators themselves? I found that they work well when they are stable, but re or under deploying them is pain in you know where.
Okay, so well, we just treated them as normal applications. We actually used this provisioning system to provision our own pipeline for each operator. So every operator had their development and production environment that got like there was a continuous delivery process, exactly like the teams had, and we deployed them to development and run tests on it and deployed them to production through our pipeline. So we just treated them as normal Java applications. And while developing, actually, we just ran them locally from our IDEs and let them connect to the Kubernetes clusters API from our machines. So we didn't even run them as containers while really by just doing development, which is really fast and easy. And because the Kubernetes API is really just the same thing, whether you call it from Kubernetes or from your machine, in the end, you can totally safely develop things that way.
And you had a separate cluster. I asked this question before you drew that part. The separate operator developer cluster, that kind of answers my question.
Yes, after the namespace deletion debacle, we had a operator developer cluster, yes.
Cool, thanks.
Okay, next question. How do you make sure you don't provision more resources than there is in the cluster?
We didn't. Like, that's actually like, I would say it's a positive side of operators is that once you would hit that problem, you could handle it somehow with like smart logic in the operator. You at least would have a place to put the logic, but we did not care about that problem. We didn't ever run into that yet. Also, what the operator creates is basically mostly empty namespaces. So in the end, we were not very much in danger of overwhelming the cluster with those. We created a lot of Jenkinses, but yeah, we were not really in the position to decide like what to do about that.
Okay, and Ryan clarified his question. I think the question is mainly about the fact that some different teams may need something different from Jenkins, and how did you handle that? Because the example Ryan gives is that if everyone is deploying, for example, only Java applications, then everyone is the same. But if there are different requirements in different teams, how do you handle that?
Yeah, good question. So we handled that basically by saying we're hands off and we just give you a Jenkins and you do whatever you want with it. That was one of the design decisions behind giving everybody their own Jenkins, so we don't have to care about what plugins do they install on it and what do they do with it. But we did help them create correct continuous delivery pipelines. So in the end, the Jenkins became like a shared responsibility. And a lot of times we were solving problems that like they screwed up their own Jenkins and we just had to fix it for them because they said that it's our fault and whatever. But that's unrelated to operators.
Okay, cool. That's all the questions for now.
Cool. Thank you everybody for listening. I hope this was useful.